Alright guys, so this is our first video for our lesson on angles and their measure. This is going to correspond to section 4.1 in the book. And 4.1 is the first section of chapter 4 where we're going to start talking about trig functions. Now when we talk about trig functions, we say that trig functions evaluate as inputs angles or rotations. And so what we're going to do on this lesson is basically get a baseline for how we want to think about angles as the inputs for trig functions. Now, most of us think about angles, we're thinking about dimensions in shapes, where basically an angle is measuring the incline at which two sides of a shape meet at a vertex or at a corner, right? If we're talking about a triangle here, we can see that we've got three angles, right? And the angles in this triangle are fixed dimensions. They're not changeable, right? When we think about angles as inputs of trig functions, we want to think about angles as quantities of rotation. So in general right here, we're going to say when we're talking about trigonometric angles, we're going to use the abbreviation trig, and then this little symbol right after trig is going to be our symbol for angle, right? Or one of the symbols for angle. We're going to say that we're talking about angles as quantities of rotation. And when we're representing angles as rotation, generally what we're going to say is that we have an initial side, which is the side where our angle begins its rotation, right? And then we have a terminal side, which rotates away from the initial side, right? And right here, that quantity of turning is the trigonometric angle that we're going to be evaluating as the inputs for trig functions. Now, whether we're talking about a geometric angle in a shape or a trigonometric angle as some quantity of rotation, in both cases we're going to use the variable theta to talk about our angle, right? And right here we've got the terminal side, just sort of point these guys out, and the initial side is obviously the side in blue, right? In general, we think that the terminal side is the ray of rotation. When we're talking about rays, we're sort of talking about these two sides as being infinite lines that are really connecting at a single point, and that's the vertices of the angle. So in general, because we don't have a shape to sort of visualize our angle with, we're going to do a couple things to help us quantify the amount of rotation that we have with our angle. And one of those things is to represent an angle as a central angle. And a central angle is an angle whose vertices is placed at the center of a circle. So right here, I'm going to start my initial side at the center of the circle and extend it out. And then I'd have my terminal side for some amount of rotation away from that initial side, extending again from the center of the circle out. One of the things that we're able to see when we place the vertices of our angle at the center of the circle is how much rotation our angle has created as a quantity of the circumference of the circle. So really right here what we're able to see is how much of the circle's circumference has my rotation covered. The amount of the circumference that our angle is covered is called the arc length, and we refer to it with the variable s. But in general right here what we're able to see is sort of how much rotation our angle has created. We're able to visualize it a little bit easier than if we were just sort of looking directly at the angle itself. A second thing we're going to do when we're talking about angles as rotation is we're going to place our angles in what we call standard position. And when we place our angles in standard position, we're placing our angle on the xy plane with its vertices at the origin and its initial side along the positive x-axis. So really what we're doing here when we're placing our angles in standard position is we're standardizing where the angle starts from. All the angles are going to start on the positive x-axis. That's where the initial side for all of our angles is. So right here, if I rotate my terminal side away from my initial side, I can basically see this angle. And since all my angles are going to start on the positive x-axis, I can compare angles. I can see whether this first angle is larger or smaller than the second angle, right, that I draw. And right here, obviously the second angle is a little bit bigger. Right? In general, we would say that angles that are created from rotations up from the positive x-axis are positive angles, And if we rotate down from the positive x-axis, we would consider those angles to be negative angles. So in general, we're going to look at standard position and central angles more as we move forward through Chapter 4. But we're also going to be using these two ideas to help us understand angles as we go through this section as well. So what we're going to do next is talk about units by which we measure angles. The first unit that we're going to measure angles with is one that we're all pretty comfortable with, I imagine, and that's degrees, right? And we would say that a degree is 1/180th of a straight line. And we represent degrees with that little circle right there. If we place an XY axis with the origin at the center of our circle to the right here, we would say that if we haven't rotated at all, we would have 0 degrees. Right? If we rotate all the way around, we would say that would be 360 degrees of rotation. If we do a half rotation, we would say that a half rotation would be half of 360 degrees, or 180 degrees, right? That would make a quarter rotation half of 180 degrees, or 90 degrees. And then, of course, if we rotate 3/4 of a full rotation, that would be 90 degrees past 180 degrees, and we would say that that would be 270 degrees of rotation. In general, when we're looking at degrees here, we can say that degrees is in what we call base 60. A full rotation is 360 degrees, right? And we can say that that 360 degrees is 6 units of 60 degrees. So it's base 60 that we're seeing our full rotation. With degrees, minutes, seconds, we have a process by which the decimal, or the part of a degree, is represented in minutes and seconds, where minutes and seconds are representing that part of a degree in a unit that is base 60. So right here, we would say that minutes is indicated with 1 hash mark, seconds is indicated with 2 hash marks. We would say that a minute is a 60th of a degree, and a second is a 60th of a minute, right? So we've got an angle here of 37.425 degrees. If we come over to our circle and represent that as a central angle, we would say that that's a little bit less than half of 90 degrees, right? So right here, if we're looking at our 37.425 degrees, we really are looking at what would maybe be approximately 37 degrees right there, and then that 0.425 of a degree, which we'll underline in green, is that little bit more rotation. We go past 37 degrees. And we're talking about representing that 0.425 in units that are base 60. And the way we're going to do this is by taking our 0.425 and first multiplying it by 60 to convert that decimal into minutes. So right here we've got 37 degrees, and right here when we multiply our 0.425 by 60, we get 25.5 minutes, right? And so now we've got 37 degrees and 25.5 minutes, right? Now that 25.5 minutes is really basically our 0.425 degrees represented as a base of 60, where when we get to all of 60 minutes, we would be at 1 degree, right? Now what we're going to do next is take that 0.5 minutes and convert it into seconds. And this is going to be even a little bit more intuitive, because 0.5 times 60 is clearly going to be 30 seconds, right? And 30 seconds is clearly half a minute. So right here, in the end, what we end up with degrees, minutes, seconds, is 37 degrees, 25 minutes, and 30 seconds. Now right here, if we wanted to go in reverse, we would take first our seconds, convert that back to minutes, and then take the minutes and convert that back to degrees. And the way we would do this is we would first go ahead and take our 30 seconds and divide by 60 to get the decimal for minutes. So right here, 30 divided by 60 is 0.5. So we're saying our 30 seconds is half a minute, right? And now right here we would go ahead and take that 0.5 and add it to the 25 minutes, so that we would then have 25.5 minutes. Divide that by 60, and we get right here our 0.425 degrees, right? And then of course we're right back to where we started with that 37.425 degrees. All right, so what I want you guys to do is to go ahead and try a couple of these on your own. So right here we've got straight degrees with A, so we want to convert 122.355 degrees to degrees, minutes, seconds. And then with B, what we're looking to do is convert our degrees, minutes, seconds into straight degrees. So take 42 degrees, 24 minutes, and 36 seconds, and then go back into straight degrees. All right, so why don't you guys pause the video and give this one a shot. All right, guys, so looking at this, we can start with A, where we're converting from straight degrees to degrees, minutes, seconds. Obviously, the first thing we're going to do is take our decimal, multiply that by 60. That's going to give us our minutes, so we've got 21.3 minutes. Then we're going to take that 0.3 from our minutes and convert that to seconds. So we multiply 0.3 by 60, and we get 18 seconds, and we can see that 122.355 degrees is 122 degrees, 21 minutes, and 18 seconds. All right. Now converting from degrees, minutes, seconds back to degrees, we're going to be doing this process in reverse. So first converting seconds to minutes. Right here we can do that by taking our 36 seconds and dividing that by 60 to get our 0.6 minutes from that 36 seconds. And right here when we divide 24.6 by 60, we get 0.41 degrees. And so we can see that our 42 degrees, 24 minutes, and 36 seconds converts to 24.41 degrees. Okay, so that's the end of this video. I'm going to stop it here, and we are going to talk about radians, which is the second way we're going to measure our rotations or our angles in the next video. All right.